welcome back. In this lecture we will focus on DC to DC type of power electronic converters that facilitate the conversion from the DC voltage level to another DC level. In particular, we will focus on the buck or the step down converter. The main learning objectives will fall under three questions. First, how do DC to DC converters work? Second, what are the operating states of buck converter? Third, what is the ratio between the input voltage and the output voltage of DC to DC buck converter? The DC to DC converter is the responsible for stepping up or stepping down the input voltage Vn to the desired level of voltage at the output Vo. The input DC source can be, for instance, a DC link called high voltage DC bus, as you will see on the next slide. The output can be connected to a battery, for example. Based on the input to output voltage ratio, we recognize the back or step down converter where the output voltage is lower than the input voltage. The other converter is stepping up the voltage and is called the boost converter. In this lecture we are going to have a look at one of the simplest form of the DC voltage conversion, that is a back converter or the step down chopper. This figure shows the typical layout of power electronics components in the battery electric vehicle. As you can see from the picture that the battery is connected to the high voltage bus via bidirectional DC-DC converter. Let's zoom in this part. When the power transferred from the high voltage bus to the battery, which charges the battery through regenerative braking, the voltage on the high voltage bus is stepping down to a lower voltage level of the battery. Therefore, this battery converter is working in the back mode. Here you can see the simplest diagram of the buck converter. At its left side is the higher voltage, the VHV bus, and the lower battery voltage, VBAT, is at its right side. In this case, the higher voltage at the left side is the input voltage, Vn, and the lower voltage at the right side is the output voltage, Vout. In the figure we show the circuit diagram of a simplified buck converter which includes only a switch, a diode, and inductor. The inductor is the main responsible for smoothing out the output current. In the figure we can see the output voltage of the converter versus time. We define T on as the on time of the switch, whereas T is the total time of the period. If the switch is on, then the output voltage is equal to the input voltage, and if the switch is off, then the output voltage is equal to 0. The output voltage is the change in between two values, Vn and 0, thus has a large ripple. As we can see in this figure, the average output voltage Vout EV in the dotted blue line depends on the ratio of the on time of the switch and the total period. The diode is called freewheeling diode, which takes over the load current in the interval when the switch is off. Based on this simple diagram, in general case, if we add a capacitor in parallel, then the capacitor will help reduce the voltage ripple from the back waveform to one shown in the blue, as seen in the figure. As we increase the value of the capacitor, the amount of voltage ripple is further reduced. In the previous slides, we mentioned that the capacitor helps reduce the output voltage ripple. Indeed, the capacitor suppresses the rate of change of the output voltage, which is reflected as a current of the capacitor. This is mainly because the capacitor can maintain the voltage to some extent by absorbing or releasing its stored energy, EC, which depends on the capacitance and the square of the DC voltage across the capacitor. While the capacitor is used in parallel to the load, maintain the level of DC voltage, An inductor can be employed in series to maintain the level of DC current. The inductor is smoothing out the rate of change of current that is reflected as the voltage across the inductor. Similarly, the inductor is able to release or absorb its stored energy, which depends on the inductance and the square of the current passing through the inductor. Let us now apply the back converter on charging the battery through regenerative braking. A battery is connected to the output and the voltage is the battery output voltage, VO. We can consider two states of operation for back converter. In the first operating state, the input source is connected to the output where it stores some energy in the inductor and charges the battery. Note that the voltage of the inductor VL is positive since the input voltage is larger than the output battery voltage. During the second state, the switch turns off and accordingly the input is disconnected from the inductor. During this state, the energy stored in the inductor is fed to the output. The graph shows the time interval T on and T off during which switch turns on and turns off over the complete switching cycle, respectively. The duty cycle is defined as the ratio of on-time period divided by the complete switching cycle. The value of duty cycle ranges from 0 to 1. As we introduced before, the step-down or the so-called back converter are widely used to reduce the level of input voltage. The output voltage of the back converter is the product of the input voltage and the duty cycle. In the application of the battery converter works in the back mode, the output voltage of the battery VBAT is the product of the input voltage VHV bus and the duty cycle. Finally, there are different ways to chop or step down the DC voltage. First is the pulse width modulation or PWM method, where the total time period of the signal T is fixed and then the on-time T-on of the switch is changed. This method is effective when the fundamental switching frequency has to be constant. In the frequency modulation method, unlike the PWM, the on-time of the switch T-on remains constant and the total period T changes. This method is used when the variable switching frequency is needed. To wrap up, in this video we focus on the most common DC to DC power converters, namely the buck or step-down converter. We evaluate two operating states of the converter during on-time and off-time of the switch. We introduced the concept duty cycle and saw how the output of the back converter is simply the product of input voltage and duty cycle.